All right, so we are live, and let's go to our neetcode. I'm sharing my screen of linked list, and the list can be represented as follow 1, 2, 3, 4. We have to reorder the list to be on the following form. So 1, it's point to 4, then 2, then 3, and so on. So let's think how we can reorder this one. So for example, here we have should be 1, 5, then 2, 4, then 3, right? So actually, it means that we need first to revert our linked list, right? Yeah, we need to revert our linked list, revert. And while we revert, we will get a tail from head. And then while head not equal to null and tail is not equal to null, we are going in these directions. Head and tail. So in some point, they can be equal to each other. Yeah, so I think that in this case, we should consider yeah, because we can have like different options. We can have 1, 2, 3, and 4, and also we can have another option like this. So here we have like 2 pointers, like reverted and the current head, and then we put this one, we put this one, then we put here and here, and when we put actually these two, we are going like here, and we should determine and actually exit from exit from our list. And I'm thinking like how we can exit. So first exit is actually we can store some set, for example, of visited. We can have a set of visited, and then if it's already visited nodes, it means that if it's visited node, yeah, so if it's visited, so for example, we put this one and this one, and then we check if some case is in visited, we just return from here and from here as well. So for example, visited contains head, or visited contains false, and here contains false. We have a set of list node, so this won't be visited. New cache set, and here we should update actually our head. All right. Yeah, so we cannot return, and we should update. Yeah, we can actually update too. So we have head, then list. So let's have it like list results. It would be equal to the head. And here we will try to update the actual exam. So we have tail and head. So head. Yeah, so we will store list node and next. It would be head next. Then we do head next is equal to tail. We can just create, I think we can create, we can create new node. With tail value, and yeah, and then do like tail equal to tail next. And then head equal to next. And also we should put in visited add head, and also visited add tail. And let's create this revert of linked list. So we have list node here, and revert. We have list head here. So so we need a previous. No, not list, but we have here list node. Here we have list node. Yes. And now we need a previous. So previous, it will equal to null. Then while head is not equal to null, we do some logic and return previous. And now what we need to do, we need to take the next of head next. Then we need to do head next equal to previous. Then we should move our previous to head, and head move to the next. Yeah. Let's run. All right, so list node. Yeah, and at the end, I think we should do head equal to results. But actually, it's a copy, so we cannot do like this. Yeah, we cannot do like this. Okay, so here we have reverted tail for 2. We should put it here. Okay. Yeah, I think this logic it will not work. Yeah. So we have 1 4, and then that's it. So we have head, yes. So it would be then next this tail, right? So 4. It would be next. Head next. And Yeah, then we put this one, head. Yeah, maybe it's something like this first. No pointer. Visited, and let's say head not equals to null. Parameter 1 is null. Yeah, I think this visit is not something that actually is correct. So let's think. I think revert function is correct. So we have here revert and with 2 pointers. But let's print it out. Let's print what we have in head value and also what we have in tail. So in head we have 1 and in tail we have 4. Okay. 1 and 4. So they actually have these values. What if we will do the following? We do like while one 4 head not equal to null, for example. We will do the following. We take head, like we create new list node. It would be next, head next. Then we would do head next equal to new list node tail value. Then tail next would be equal, tail would be equal to tail next, right? And head would be equal to next. Yeah, I think it should be something like this, like head. We have head, then head next would be equal to this value, and next it would be head next, right? So it would be this value, then we take a head next, then we do head equal to the next, and also tail to the next. We have 1, 4, then 2, that this moves to 3. Then we have 2 and 3. And after 2, they swap each other. So I think that, yeah, so here should be done something differently. So let's think. So we have head, we have next, head, next, equal to tail value. Next it would be head next. We can do like next. Then tail equal to tail next to 3. And head equal to head next. Memory limit, yes, because we didn't add. So if we will have again this set of list node, like visited, new hash set, and it means that if visited contains head, we break, and here what we do, we put like this: visited add head. So first of all we add our head here, and then we also add tail. Time limit. Okay, let's think why it's time limit. So let's print visited. Okay. Yeah, because here we create all the time the list node. What if we will store integer and we will store here value and here value as well, and here value. Head next. And next. Do you actually need this next? One, 4. So we add 1 and 4, and then head next. Yeah, so I'm thinking head value plus set or visited. So let's verify this. Okay, so we have 1 as a head. So we put 1 and then we go to the 4, right? So we go to the 4, head is equal to 4. Next. next equal to new node with this next. So what actually we do here? So we have 1, 2, 3, 4. We have nodes like this, right? So we take this link to 2. Then we have this 1, and we are telling, okay, so now we create a new for next. We create new node with 4 that is pointing to the 2, 3, and 4. Right? So we actually here we are adding the new node to 1, this 4. And after this, we actually add 1 and 4 to our list. And we are telling that now tail, like now head, would be pointing to 4, right? And here our tail would be pointing to 3. And now when we are on 4, we take 2. We take 2. Yeah, so I think here we should be like next. No. Okay, so yeah, we are quite struggling here. So let's think about another way. So we revert this linked list. So yeah, I think that maybe we don't need to visit it. And yeah, let's think about this. This thing, how we can do this. We have 1. We actually add 3, and then we should stop. So in which case we should stop? Yeah, I think we should still have it, and we should stop if visited contains head value. We return, and here we always add to visited tail value, and here we have head, so we should create a new list node, this would be new list node. Yeah, new list node with tail value, and we need to store next node of head. Then we should do head next is equal to new node, and then yes, and then like 3. 4, then 3, 2, yes, and then so when we create this 4, we point head. Yeah, we store this 2. Then we get like head. Yeah, next we point this one to 4. Then we get like end node next would be equal to next to 2. And then we are telling that head would be equal to this one, and tail is equal to tail next. Okay, 1 and 4 as results. Why? Why 1 and 4? New node 1, 4. Yeah, still don't understand. So head next over 2. Then we do like this. Head next, it's new node. Head next, new node 4. 4 will be pointing to next. Head. Yeah, so head next to 4. Then next would be equal to this 2. Then head equal to the 2. And tail is equal to the 3. So and when we add only 4, yeah, yes, makes sense. So here we actually return it from here because the next head is 4, but why 4? Okay, so let's print it out. System out print len and head value, and let's check what we will print. We print only 1, and then somehow head becomes empty. So new node next is actually this next. So I'm super surprised that actually here this one is empty. Why it's empty? Why it's null? So head next. What we have next? What we have here? It's also null or what? It's null. It's null. It is null. Interesting. Yeah, actually, why I'm doing this, so I can just store all values in the stack, and yeah, so I put like 1s and 2s and 3s and 4, and then I have like pointer to the first string. Then I take 4, I create middle element, I go to 2, I take the next element, I go to 3, and when I have already visited, I'm just skip and just return. So I can do this way. Yeah, I can do this way, and I think it would be even easier because I think that's a problem here with revert function or something like this. So let's quickly create a stack of integer stack, new stack. Then we just iterate over our so we can create a TMP equal to head, and while TMP not equal to null, we just put into the stack TMP value, and then TMP would be equal to TMP next. Okay, so here we have a stack, and then we just do for each from 0 to I stack size divided by 2, I plus plus, and here we have this head value. So what we can do, we can we can do like this. So we have head, we store, we create a next node. So it would be next, we store head next, then we do head next equal to new list node from stack pop. Yeah, so we pop in this from the stack, and yes, and then this would be a next value here. It would be the next value. One, 2. So we pop 4. We have 2. Then we pop 3. Oh no, it will not work this way. Okay, so let me try to check solutions. Yeah, because we already solving it for 34 minutes. So let's check solutions. I think even on neetcode we can try to search it like here. We can check solution. Okay, so we have prerequisites. So before attempting, you should comfortable with linked list fundamentals, understand single linked list. Okay, we know this. Fast, slow pointers. Using two pointers, move it at different speed to find the middle of a list. Linked list reversal. Reversing, yeah, we can do this. Merging linked list, we can do this. So what is brute force? To reorder the linked list, a straight approach is to store all nodes in array. Once stored, we can easily exit nodes from both the start and the end using two pointers. Yeah, so that's actually what we are doing here. Not with stack. Yeah, it's correct that maybe we can just store some list integer and the new array list, and then we have this list node TMP that will be equal to head. Then while Yeah, so as we actually did it previously, so we don't need to implement this. So just instead of stack, we have a list of integer new array list, and here to list we add values, and then what we can do, we can just have pointer I and pointer j, list size -1, and while j -1 is greater than 0, we actually put our values. So here we had a head, so head would be always our pointer, and head next would be equal to new list node with list get at j, and then yeah, so we have actually the next node. So we create that 1 is pointer to 4. And now we should have 2. Yeah, we should have 2. So we can have kind of a k that is, yeah, we need to understand from each side we will take, right, this element. So let's think. Let's check how it's implemented. Yes, so it's even list nodes. All right. So we create list, then we have current head. Yes, so we add all to the list. Then we have 2 pointers. We get head. Nodes. Yes, so nodes get next equal node get j. All right, so yeah, so here we actually reorder them. So we collect all nodes, and then we have 2 pointers, and we are telling that this one is pointer to this node, and then we increment, and if I is greater than, we break, but actually we can just put it in while loop, and node j next is equal to this one, and we increment. Okay. And then nodes get I next equal to null. Yeah, makes sense. So here, instead of integer, we can just store these lists, and then we have not a stack, so we can just store this list nodes. Then we have this both. Then we do like this: list get I next is equal to list get j, right? And then we increment our I, and then list get j next equal to list get I, and we decrement our j, and then list get I next equal to null. Let's run it. Now let's submit. Yeah, so it's working, but it's too slow. Space and end. So we have recursion. So we can do it in recursion call. So root and current next. Yeah, I think recursion is the same, but it's more complex to implement. So reverse and merge. We have reverse and so it's fast and slow pointer. Yes, I think this one is the most complicated one. So we have slow and fast pointer, and while fast not equal to null and file next not equal to null. So here we have second, slow next, and previous. Yeah, so let's check how we can check it. Okay. So how it works, so first we have pointers here, then we move slow pointer to 2 and fast pointer to 1 and 2. So they still not equal to null. So we again move our slow pointer to 3, and now we go out. So we have slow second and slow equal to next equal to null. Previous second. Head finish. Okay. Yeah, I think it's much more complicated solution. And yeah, quite complex problem. Let's check discussion. Yeah, so we see that it's quite complex question. But yeah, I'm good that we at least solve it in easy way. So let's see you tomorrow.